If I want to now create a cap for it, it is very easy for me. All I need to do is take this cut surface here. It is possible for me to trace all these lines and find out what is the thickness with which I can go inside and so on. Since in the beginning itself I have made certain things saying approximately this you see here this thickness to this thickness, some various what do you call design considerations I have done. It is safe for me to right now to take maybe about half the thickness. So, coming back to this point here, now I can try to make certain things to make sure that things will what do you call sit properly. So, I have a top surface here by which this is one face which is there, this is one face. I will see what best I can what do you call surfaces from objects. This typically represents the corner to corner which I have, and inside I will hide it. Inside I have another surface. Some bug. I will do it instead the other way, saying I will create a you see here I have two planes. One of these planes I will extrude vertically up, the bottom one, inside one, this could very well make my cover. See here, I have a beautiful cover. Now, I need to do something to make sure that this cover will go and sit on the other things. This is where right now, no, I will not optimize. There is a lot of unnecessary material here. Actually, I just wanted a small rib all around. So, it is possible for me right now. I will use it as it is. I will what do you call copy both of them, hide one set, then I will solid the thing. I am sorry, what do you call union this whole thing, make us a single solid. What happened? Yeah. Some reason it is what do you call as a small zero thickness issue. So, it is not what do you call easily joining together. I will just leave it as it is. Instead, I will what do you call group them together, and now get back to this and try to oh. Hey, what happened to all my parts? Yes. Oh, part of it got cut. Anyway, you can just still see. What I wanted to do was saying whether I can create a step here on the top. Right now, probably it involves a restart. So, I will avoid the restart. Instead, I will lift it a little and see where the problem could have been. See, in principle, there is no issue about it, because this thickness is here. You see, that thickness has been put into this, and this I expected, no, it will give me a little leeway. I need to restart it. Maybe I will get back and do it next time. Right now, well, I just wanted to show you that I have a cover on top, and the problem being this thickness on the left side, I have not dealt with it properly. So, it is possible for me to make a cover which is just a little smaller than this. It should not be the full width. That is where the problem has started. You see here, this should have been a little what I call smaller. I will see if I can handle that thing in a different way. Yes, slowly. Yeah, it is a little narrower here, little narrower here. Now I will see. So, if I see here, I notice that there is a small step and all these sides is a little smaller than required. It is a question of my lowering it now and then try to remove the materials. Here is where I thought I will show you a very interesting thing. You have these cylinders, you have seen that the cylinders are almost coming to the total height of it. Now, I need to play a lot to get the cylindrical shape there, which I thought intuitively I will do it, but it does not seem to work like that. So, what I will do now, I will take all these 4 cylinders up, make them touch there, hide the slot and do a with all my this what you call tricks, you may just notice that I have managed to make some small depressions in the top portion, which will be useful for me eventually. You have noticed it now. When I look at this cover, you see, I managed to get the circular portions of it, which was part of the cells, to be on the top side, which is, it gives me a small advantage of when I place them. If it was circular, there is a little issue about it, but if it is in the other way, the other features can be there. Finally, when I close it fully, that whole thing can be sealed inside. I started with the top cover with a little this thing. I will now just see how well see here. Finally I got it. See here in the corner, I have a small step here. All around I managed to get the small step because of some what you call this is only a surface modeler, it does not come well. After I finish it, I will sit at outside, I will sit outside and see how well I can bring these things together. You see here, that was the concept. Intentionally that cells have been raised, and then you see here on the top cover I have a small projection here. You have seen that it has almost come to the edge. Because of some problem, this what I call, there is an extra plane here which it got cut, and it is not able to show up properly. So, eventually I will have a cover which will sit on this. This is where a little bit of what you call our ingenuity is required, or this thing saying, do I now pack it with a little bit of elastomer material, or in this case I can even put it with RTV compound, the same silicone sealant which you use for windows and all that, just a dab here and there. Once you close it and take it back, it will make sure that these things do not rattle, and it will follow whichever it is. So, I think I have taken a bit of a thing. I just wanted to show you how it is possible to build all these things. Now, I have two objects which need to be laid up and built. See, I have repaired it a little due to some error. It has boxed the whole thing, sorry. I will build it up afterwards later. So, I have one part there, one part here. Now, it comes the our what do you call whole way of producing it. If you just want one piece, it is possible for me to build it up by keeping this flat. And start the machine and have this built up. Now, we will notice it, if you want to make this in a mode like this, we may end up with the way things built up and all that. So, it is more common practice that you make maybe 2 or 3 of them in one file separately, make 2 or 3 of these things in another file separately, and start the building up, so that you will know how things are, and maybe you can do a modification. I will just briefly, I will show you now, saying I will export this object. This is what we have created in the assembly. This is a fairly completed object, and it is easy for me to start building here. Now, if I see here, there may be some problem in one case. In this case, no, it has cut and it has come out like this. Is this preferred, or would I prefer this? So, these things, out of practice we need to what you call, see which one of this. There is no one universal rule for it, but I still prefer in some cases this being open like this. In some cases we need to make it into a box structure, and then since that has in case that has a axial movement, probably we need this side also to be open. The issue is not so much as now we need to send this. I will repeat it again and again. I need to now send this as STL file. This has been created now into a stereolithography file. The advantage of the lithography file is that it is a collection of lot of meshes. So, I have a lot of control on this in another program, and if I now close this and see where the STL file is there, I hope it opens well. I have not checked it. I am lucky if it does. You have seen here. Oh, it is lucky. Our creator is with me. You have seen, I have noticed something about it here. What looked like a simple common thing is it's a collection of lot of triangles, and first time all that surfaces what we have shown so far and partly which has become solids have become converted into this mesh of triangles. This mesh of triangles is now used by a patch program by the other build up what I call machines, and for practical purposes it does look like this, but depending on the resolution and all that, no, it builds the model. So, if I now this thing, can you see how many every radius has ended up with so many triangles here. We have an advantage, we have a disadvantage, and then if you see while creating it, we have to be a little careful about it. While creating a solid model appears a little intuitive and easy, that layup machines or the what I call fused filament machines use this for generating the other things. So, little bit I will just what I call probably stop it here. Sir, can you focus me on my this thing, then surface? Can I see my monitor? If you take any plane, if this were to be a plane, any 3 points you can pass a plane through that. So, that is the starting point of all the CAD. So, if I will just close it at this point, and what I wanted to show you also was the file lengths. You see this file, typically is only 221 kilobytes, and you see this file, this is slightly bigger, 287 kilobytes. As more and more radiuses and more features come into place, these files become bigger and bigger. So, I will come back to this. Oh, there is a commercial thing here. Imagine this is single plane. In space, you can have one single plane through any 3 points. Okay. The moment there are 4 points, it is possible that you will have something flexed like this here. You understand? And if you want a smooth radius, you have to build all of them using more and more triangles. So, I am sure some of you remember building a globe. If you have a globe, simplest way of building is make arcs, so many arcs, offset the arcs, and then when you put it like an orange peel, the top closes and the bottom closes, so that the center equatorial region does not what you call fall apart. If you just make them 90 degree out of phase, we can expand the whole thing into one space. The other option is to use the geodesic type of dome, in which if you see a typically I do not know which ball, maybe a football or something, no, it has hexagons and pentagons. So, around every pentagon you have 5 hexagons. So, you see here with that, no, it has to be, if it is all are hexagons, they will continue to be flat, but if one of them is removed, then the flexing will start. You build the whole dome around it. If it is a single dome, is a single thing, it will only made of hexagons and pentagons. Maybe you should look it up on the internet. And then I used to give it to the students here, saying why don't you build a small thing depending on the resolution of those things. Minimum, there is a minimum number which is where the I mean all of these things are developed. I will stop here at the moment. So, what I have shown you so far is where to start with a cell and then how to make a box around it, which I have shown you already. Morning I showed you about it, saying is it possible for me to make a box, see here, okay. And then how do I stack them? Do I stack them square like this? And then how to create the small details? There is a lip here, and then in this case I have not covered yet how to make a hinge, how to close it and so on. And then some very elementary things relating to how to build a prototype which can be used, it is a solid model which can be used for printing every time. So, I will stop here, thank you. We will continue with a more practical model next time. So, thank you.